Dear all, in this video I will solve some problems of National Standard Examination of Physics 2022. This video is very useful for the students who are preparing for the International Physics Olympiad and Asian Physics Olympiad. This video is also very useful for the students who are preparing JEE and also NEET UG competition. And in this video I will solve some problems of NSEP National Standard Examination, which is first level examination of Olympiad, Physics Olympiad, and in this video I will solve some problems of 2022. And on the screen you can see the first problem, that is a particle moves along a straight line. Its displacement s varies with time t according to the law s square equal to at square plus 2bt plus c. ABC are constants, and we have to determine the acceleration of the particle, and these are four options. So we know that s square equal to at square plus 2bt plus c, and we have to determine the acceleration, and we know that acceleration is d2s upon dt square. That is the acceleration. This is acceleration. So we have to differentiate two times this equation, and if we differentiate one time, then it becomes differentiation of s square, that is 2s ds upon dt, and differentiation of at square is 2at plus differentiation of 2bt is 2b, and this is a constant. Differentiation of constant is 0, and we can cut 2, and this equation becomes s ds upon dt equal to at plus b. Now suppose we can write it ds upon dt. ds upon dt means velocity, and this velocity becomes at plus b upon s. Now actually we have determined d2s upon dt square, so we should differentiate again this equation, and if we differentiate, it becomes first term as it is s, differentiation of ds upon dt, it becomes d2s upon dt square plus ds upon dt as it is, and differentiation of this term s, it is again ds upon dt, and in right side differentiation of at is a, differentiation of t is 1, and differentiation of b is 0. So it becomes s d2s upon dt square plus ds upon dt whole square equal to a. This is now we can put, we know that this is ds upon dt. ds upon dt is at plus b upon s, and we can put the value of ds upon dt in this term, and it becomes s d2s upon dt square plus ds upon dt means at plus b upon s whole square equal to a, and we can write it as, or we can write d2s upon dt square as equal to a minus at plus b whole square upon s square. Or we can also write, we have to determine the d2s upon this d2s upon dt square. So d2s upon dt square equal to, we should divide by this s, a upon s minus AT plus B whole square upon S cube. And S cube, if we take LCM of S cube, it becomes AS square minus whole square of AT plus B whole square. It becomes A square T square plus B square plus twice ATB. This is AT plus B whole square, and again this is S cube divided by S cube. AS square, A S square, put the value of this S square. Value of S square is given in equation AT square plus 2BT plus C. So we can write AT square plus 2BT plus C minus, it becomes A square T square minus B square minus 2ATB, and S cube, it becomes A into AT square, A square T square, A into BT plus 2ABT plus AC minus A square T square minus B square minus 2ATB. A square T square cancel out and 2ATB cancel out, and it becomes AC minus B square upon S cube. This is D2S upon DT square, and ACB in questions, ACB are constants, ABC are constant. It means ACB in numerator, these are constants. So D2S upon DT square is inversely proportional to S cube, or we can say D2S upon DT square is directly proportional to S to the power minus 3, and we can say that in this question, this option, fourth option, is correct. This is first problem of NSEP 22 examination. Now we will move towards the second problem, and second problem is a ball A mass m1 moving with velocity v experiences an elastic collision with another stationary ball mass m2. This is mass m2, this is mass m1. Each ball files apart symmetrically relative to the initial direction of motion of ball A, and at an angle theta, ratio of masses of ball m1 upon m2. We have to determine m1 upon m2, and we can understand the diagram. This is the ball mass m1, velocity of this m1 is u1. This is stationary ball, this is stationary ball, a ball A, this ball A, this is ball A moving with velocity v. Suppose this is velocity v, experiences an elastic collision with another ball B, stationary ball B. It means velocity of ball B is 0. Each ball flies apart symmetrically related to the initial direction, and we can consider that one ball is moving in this direction and one ball is moving in this direction, and this is angle theta. And we can consider that suppose this is ball A and this is ball B, and we can say that suppose after collision velocity v1 and velocity v2, and component of v1 in this direction we can say v1 cos theta, and component of v2 in this direction V2 cos theta. And in vertical direction, component of V1 is V1 sin theta, and in this direction we can say V1 sin theta. And as it is a elastic collision, so we know that in elastic collision there is a conservation of linear momentum and conservation of kinetic energy. So we can say that if there is a conservation of linear momentum, then m1 u1 plus m2 u2, it should be equal to m1 v1 plus m2 v2, as we know that total linear momentum before collision and this is total linear momentum after collision. And in this case, which is given in figure, there is a mass m1, velocity of u1 is v, and mass m2, velocity 0. And in case of horizontal component, we can write m1 v1 cos theta plus m2 v2 cos theta, and we can write m1 v equal to m1 v1 plus m2 v2, and cos theta we can take common. So it becomes m1 v equal to m1 v1 plus m2 v2 cos theta. In case of vertical, before collision there is no horizontal there is no vertical component of m1 v, and second m2 mass is stationary. So before collision, vertical component of both ball in vertical direction is 0, and after collision it should be m1 v1 sin theta, and as direction of vertical components are opposite to each other, so it should be minus m2 v2 sin theta, and we can write m1 v1 sin theta, it should be equal to m2 v2 sin theta, and sin theta are constant, cancel out. We can write it m1 v1 equal to m2 v2. So in this equation, suppose it is first equation, in this equation we can write m1 v in this equation m1 v equal to, sorry, this is v, this is v. So m1 v equal to m1 v1 and m2 v2 both are equal, so twice m1 v1 cos theta. m1 v equal to twice m1 v1 cos theta, m1 cancel out, and it should be v equal to 2 v1 cos theta. Now we can apply the elastic condition of elastic collision for conservation of kinetic energy, and conservation of kinetic energy is, we know that half m1 u1 square plus half m2 u2 square equal to half m1 v1 square plus half m2 v2 square. This is conservation of kinetic energy. We can half is cancel out, and we know that kinetic energy is scalar quantity, so there is no need to take the components of kinetic energy. So m1 u1 square becomes v square, and velocity u2 is 0, so it becomes 0. m1 v1 square plus m2 v2 square. And in this question there is a requirement of m1 upon m2. We have to determine the value of m1 upon m2. So we can write it m1 v square equal to m1 v1 square plus m v2 square. If we multiply numerator and denominator by m2, then it becomes m2 square v2 square upon m2. And we know that m1 v1 equal to m2 v2. By this equation, we know that m1 v1 equal to m2 v2. So this m2 v2 may be replaced by m1 v1, and equation is m1 v square equal to m1 v1 square plus m2 v2 square. We can write m1 square v1 square upon m2, and we can cut one m1 from left and right side, and it becomes v square equal to v1 square plus m1 upon m2 v1 square, and v square, we can take v1 square common, and it becomes 1 plus v1 square, 1 plus m1 upon m2. This is m1 plus m2, and we know that v1 square is v equal to 2v1 cos theta. So put this value of v in this v square, it becomes 4 v1 square cos square theta equal to v1 square 1 plus m1 upon m2, and v1 square is cancel out, and 1 plus m1 upon m2 is equal to 4 cos square theta. And in this question, we have to determine m1 upon m2. We have shown it in this circle. We have to determine m1 upon m2. So m1 upon m2 equal to 4 cos square theta minus 1, and we can write it 2 cos square theta minus 1, and it becomes minus 2, so we have to add 1. And 2 cos square theta minus 1 means cos 2 theta, so it 2 cos 2 theta minus 1. m1 upon m2, it should be 2 cos 2 theta minus 1. So in the given 4 option, the answer is 2 cos 2 theta. Sorry, it should be plus 1. 2 cos 2 theta plus 1. 1 plus 2 cos 2 theta. This is the right answer. C is the right answer. So this is question number 2.